off there a little bit. I'm sorry. So again, we're looking at the number of eggs used and the number of cakes baked. Okay. So the number of cakes baked, right? We can bake as many cakes as we want. But the number of eggs we use completely depends on how many cakes we need to bake. Okay. The number of eggs we use completely depend on the number of cakes we baked. Right. So our cakes would be our independence by itself, where we can bake as many cakes as we want. But the number of or eggs we use depend on how many cakes we end up with. Okay. I'll do one more and then you can try the last two on your own. The number of students in attendance at school and the number of lunches served. Okay, the number of students in attendance at school and the number of lunches served. So the number of students in attendance at the school is independent, right? We can have as many kids as we want at our school, but we're gonna have to feed them, right? So the number of students we have at schools are independent. It doesn't mean anything. But the number of lunches we serve completely depends on how many students are at that school. Okay. If we have 600 students at the school, we're going to serve 600 lunches, right? Of course, this is saying like everyone goes to the hotline line, right? Everyone gets the main dish. If you have 500 students at the school, you're going to serve 500 lunches. So your lunches depend on how many students are at the school. The students are in attendance is your independent variable. So try the other two on your own. Think about it. Hopefully, you are starting to understand. But the official definition of independent dependent variable, y'all, is this: when one quantity depends on the other in a problem situation, it is the dependent quality, right? It depends on something, okay? But when the quantity it depends upon, that quantity is the independent variable, right? It can be on its own. It doesn't need anything else. It can do what it wants. It's the independent quantity. Okay, so those are some key definitions there for you. All right. So this next activity here, okay, we are going to be looking at some scenarios, and now we're going to try to connect them to graphs. So while a person can describe the monthly cost to operate a business or talk about a marathon pace or run a marathon to break a world record, graphs on a coordinate plane enable people to see the data. Okay, you're going to see graphs throughout your life on news broadcasts and different things when you have a job. Okay, graphs relay information about relationships in a visual way. It helps us visually see what's happening in a scenario. You can use lines or smooth curves to represent relationships between points on a graph. In some problem situations, on the point on the line will make sense. In other problem situations, not all the points will make sense. So, when the model relationship is a line or a curve, it is up to you to consider the situation and interpret the meaning. So that's what we're going to be kind of working on, right? Okay, so our first scenario here, Grayson completes a dive from a cliff 100 feet above a river. It takes him only 1.7 seconds to hit the water. Okay, so I'm going to go ahead and I'm going to exit out of this. Okay, because I do have. Hold on. Things we're gonna look at right now. So give me 1 second. I gotta pull it up. Okay, so scroll down. All right, it's kind of hard to see. So we're looking at the scenario of this right here. Grayson completes a dive from a cliff 100 feet above a river. So if we're kind of just looking at this right now, okay, A is starting at the baseline. Well, he's above the ground, right? We're not at the ground level. B is also looking at the ground level. C is not, right? C is above, so it could possibly be C, it could possibly be D, E, F, G, not possible for G, right? Or H. Okay, so these are the possibilities that we're looking at. Grayson completes a dive from a cliff 100 feet above a river. All right. C is going back up. Doesn't really make sense, right? So I'm going to go ahead and cross out A, B, and C. D is doing this curve. I'm not sure that really makes sense in our problem situation. E, though, right? If I'm looking at E, that looks like a jump. I would say E would match that problem situation there as well. Okay, so I recommend going to the next video. We're going to go through a few more of these to make sure we have a clear understanding. And then we're going to kind of talk about how to identify independent dependent variable. And then you can do your activity. Okay.